Hello, Shasta High School Honors Math 1. This is Mr. Roberts, and this is a look at the study team test that we took for Chapter 8. I'm going to quickly go through these questions. Please skip forward, just look at the ones that you need to review perhaps. And if you have any questions, stop by and see me in class. So the first one, there's just two of them. It says to solve the system of equations, and you may either use elimination, substitution, or equal values method. It says your work must be neat, clear, and easy to follow. So when I look at this first one, I think probably almost all of you would immediately say, hello, I'm using substitution. I don't even need to multiply by anything to get the y variable to eliminate. When I combine these two equations, I end up with 5x equals 20, and you can see right here, right, these add up to give me the 5x, and then a positive x and a positive y and a negative y is 5, and then the 15 and 5 is 20. Again, the logic behind this is if you have things that are equal, for example, if I have an expression a is equal to a, and I look at this expression b is equal to b, if you have equal things and you add equal things to it, you get something that's also equal. So this would give me the a plus b is equal to a plus b, right? So look real closely. I've got equal quantities, and I'm adding to each side of that equal quantities. Therefore, I'm getting equal quantities. It just so happens that what's nice is when I add them like this, the positive and y and negative y eliminate, and I'm left with just x variables. So if I divide both sides by 5, we quickly get that x is 4. And if I feed that into either one of the original equations, we can quickly figure out what y is. So for example, if I could look at 2 times x plus y would be 15. If I plug in that x is 4 there, that's 2 times 4, which is 8, plus y is 15. And then finally, if I take away 8 from both sides, 15 minus 8 is the number 7. So y is 7. So my solution is the point x is 4. Whoops, not x is 4, just x is 4 and y is 7. And when we look at part B, could probably use elimination as well, but I'm going to go ahead and isolate y from the second equation. So if I do that, this would become the opposite of y equals negative 5x and then minus 3. So I subtracted 5x from each side of that, and I'm going to multiply both sides by negative 1. That'll give me that y is positive 5x plus 3. So this is a very nice value that I can use to substitute into the first equation. So if I'm looking at the first equation, I'm going to write 3 times x plus 8, but instead of y, I'm going to use 5x plus 3, and that would equal 24. So we'll apply the distributive property. 8 times 5 is 40x, and 8 times 3 is plus 24, and that equals 24. That's interesting because now all of a sudden I've got 43x, and I can take away 24 each side. From each side is 0. Therefore, x is 0 divided by 43, which is 0. So, I've got that x is nothing. And to figure out what y is, then I could plug that back into this equation, and 5 times nothing is still nothing, plus 3 is 3. So the solution to this system is x is 0, y is 3. And real quickly, you can verify that. 3 times 0 is 0, 8 times 3 is 24, 24 is 24. It checks in the first equation. 5 times 0 is 0, and then the opposite of 3 would be negative 3, and that's negative 3 on the other side as well. So it checks in this equation as well. Probably be smart to do a similar check for part A as well. Anyways, that's question number 1.